Right, I think we will get started. Good afternoon, everyone. Welcome to today's session on the opportunities of the built environment. My name is Matt Black. I'm the Climate Action Manager at the World Green Building Council. In terms of today's session, I'm going to give you a little bit of an intro and an overview of what we're going to discuss, and then we'll hear some brief presentations from our wonderful panelists. And after this, we'll get into a discussion about the topic, the opportunity of the built environment. And I've already told them, I encourage you to ask each other questions and get involved. But even you guys, if you have a question as it pops up on what we're discussing, stick your hand up. Let's not wait till the end, otherwise you might forget. And we can pass you the mic, even though you might have to come here because it doesn't stretch that far. And we'll try and make it as engaging as possible. So just in terms of a bit of an introduction, if you're not familiar with the World Green Building Council, we are the most influential global network of its kind in relation to the built environment. We have over 85 national green building councils across the globe, and they collectively represent over 53,000 members, reaching 80% of the global population and 91% of GDP. So together with our network, we're accelerating the transition to a sustainable and just built environment. But today, we're going to talk about what is the opportunity of the built environment. It's the second biggest contributing sector in terms of carbon emissions, broadly accounting for 38% of energy and carbon emissions. It's a massive challenge, but that challenge also represents an opportunity. And I think broadly we're gonna cover an awful lot with the three panelists that we have today. But to sum it up a little bit, there's obviously the environmental opportunity. Because it's such a big sector, it's a massive opportunity in terms of reducing emissions, achieving that impact, not only in terms of decarbonising, but also in terms of improving resilience of our communities and our cities through that process. It's also an economic opportunity. It's an opportunity for investment, it's an opportunity for jobs, and on an individual level, for a lot of people, it's an economic opportunity in terms of saving costs in relation to their energy bills and beyond. And finally, often forgotten or maybe not touched on as much as those two, is the social and equity opportunity that the built environment represents. Every day we exist in buildings, whether it's your home, your workplace, your school that you send your children to, your hospitals. We spend a lot of time inside them, and the way that we interact with our buildings is really important. And so putting that effort in, not only to decarbonise them, but to improve their resilience, to adapt them to the challenges that we face, is really important and can contribute to multiple co-benefits in terms of social improvement, improving equity, and health and well-being benefits as well. So I think hopefully that's pretty clear. And one of the things that we're always keen to point out at World GBC is that, it's not rocket science. Most of the solutions, if not all of the solutions that we need to actively decarbonise the built environment exist today. Many leaders are already implementing them. But now, as we enter this era of implementation, this COP for action, it's about massively scaling up the implementation of those solutions and getting that impact felt by people all across the world. So, I think that's going to be enough for my little intro. We're going to hear from each of our panelists now to give a brief presentation on their topic for today, and then, like I said, we'll go into a discussion with the rest of the panel. So, to begin with, I'm going to pass over to Elinor Huggett. Elinor, will you also introduce yourself, where you're from, and then get going?
Sure, thanks very much, Matt, and lovely to be here. Thanks everyone for joining. Thank you, Shaun and Eliot, for so good time. I'm Elinor Huggett. I work for Foster & Partners, who you may know of as a global design studio, primarily architecture. So we design buildings of all scales, from kind of individual buildings all the way up to new cities, transport-oriented development, you name it, we design it. So I'm coming at this very much from that kind of design and construction angle, thinking about what changes can we make to the way that we design and build the built environment, in order to enable some of the things that Matt was talking about. And I think one thing that we're very keen to think about is that the statistics Matt gave us about the contribution of the built environment to carbon emissions, around 38% of carbon emissions coming from the built environment. It means the built environment is very often presented as a problem, but I think it's really important to understand that the built environment is essential. You know, Matt described all of the ways that we interact with the built environment in our day-to-day lives, in our homes, our workplaces, where we go to school, hospitals, you know, all of those things. We need buildings, we need infrastructure. And so just looking at the built environment purely as a problem isn't going to help us. We have to understand, okay, this is absolutely essential part of our lives. Currently, the way it operates is quite polluting, so we need to think about how can we change it to make it part of the solution. So make it not only enable all of the great things that Matt was talking about in terms of happier, healthier people, social value, improving people's lives, but also at the same time improving the environment, so reducing the carbon impact of that. So one of the things that probably you've all heard a lot about is the impact of the materials that we use to build buildings and infrastructure with. And we are seeing kind of an increasing market share of what we call bio-based materials, which are, using the name, they're materials that come from more organic sources. So timber is a really, really clear example there. Lots of other examples as well. You know, for example, there are types of fungus that you can grow which can have some contribution and form some parts of buildings. But I think what's important to be really, really conscious of is that while the application of those materials is growing and the uptake is growing, and it's absolutely brilliant to see that, we will continue to have a need for the kind of more polluting materials like steel and concrete, which we've all heard about. So at the same time as increasing the market share of those bio-based materials, we also need to be thinking about circularity, so understanding how we can reuse things much more effectively. And that is in essence a design point, because in order to be able to effectively reuse materials, you need to design your structures in such a way that they can be taken apart and those elements can be put back into the supply chain. So that's really increasingly impacting the way that we think about designing buildings. So how can we use things like modular and off-site construction, which means that you essentially have a kit of parts, you put your building together, it's much quicker, it creates much less waste, and then you can just take your building apart as well when you're ready to do something else with it. So it's these kinds of layers of what type of materials we use, how we use them, how we set up a design to use them in the most effective way possible, and considering that whole building life cycle, I think is absolutely key. So in terms of really that reduction of the impact of the absolutely essential built environment, I think it's really a significant mindset shift that the sector is going through. I'm not even going to say it has to go through it. It is, but the sector is going through it, and we have these conversations now on all of our projects, and our clients ask for it, and we're seeing legislation move in that direction as well. So I think in terms of the opportunity to reduce the impact so that we can start seeing the built environment not as the problem child, but as part of the solution, is absolutely there and it's happening. And as Matt says, we just need to scale it. And I'm really interested to hear from colleagues Shaun and Eliot, because they're going to look at slightly different angles to this conversation. So I'll pass on now to Shaun.
So, my name is Shaun Fitzgerald. I'm the Director of the Centre for Climate Repair at the University of Cambridge. And I have a very, very keen interest in the role of the built environment. So, before taking up the reins as Director of the Centre for Climate Repair at the University of Cambridge, I spent 12, 15 years working in the construction industry. So some of it was as an academic, other times, the majority of the time, I was a founder, and then I ran a company called Breathing Buildings doing low energy network ventilation. And actually had the amazing privilege of collaborating with Boston partners on various projects about trying to reduce the energy use of buildings, but thinking holistically also about the amount of energy and associated carbon with the construction of them as well. But since returning to the more academic environment at the University of Cambridge, begun to think about actually what the opportunities are even greater, thinking out of the box for the role of the built environment, and especially the future buildings. It's an old sort of saying that if you want to make a difference in the built environment, it's actually new build is the easy stuff and it's the low-hanging fruit. The really hard bit of the existing buildings, but we do need to use those opportunities in the new buildings if we possibly can. So I'm going to use some visuals to help us sort of walk through some of what I think are the real opportunities. I'm just going to skip through some of this stuff, if that's all right. The first thing I wanted to touch on was Elinor's comment about just the use of materials. But if we really think about the role of the built environment, and on the slide here you'll see examples of steel, but also examples of timber. And just thinking about the role of timber in construction, you might think, well, that sounds like a nice way of reducing the emissions that would otherwise have occurred if you built them out of steel or concrete. But I think it's rather deeper than that. And that is, if you really think about one of the forms of tackling climate change and actually sequestering the carbon dioxide in the atmosphere, if you grow trees and you have an afforestation plan, that's all well and good, but we run into a problem after about 100 years, when actually what happens to that tree once it's grown? Because actually what you'd really like to do is to then use that land to continue growing further trees. So, you've got a number of options. You can go and bury it, you can go and turn it to charcoal and get that into a stable form, or you can use it for things like buildings, and therefore they become part of the solution. I know nature's doing the sequestration bit, but if you really think about in a system approach, then there are real advantages to trying to use more natural materials in the built environment, and I think in particular of timber where possible. What I really want to touch us on though is we talk about reducing emissions in the built environment, and very few people are actually thinking about what the opportunities are in the built environment to actually actively remove greenhouse gases. And that's a really wild and wacky thing to think about. Just what can we do to reduce emissions, but flipping it on its head, can the built environment be a force for good? And one of the things that's really sort of tackled my sort of brain cells over the last 4 years is worrying about methane in the atmosphere. So broad brush, methane is about 200 times more dilute than carbon dioxide in the atmosphere. So the numbers are this. Carbon dioxide, call it 420 parts per million, methane about 1.7. I'm an engineer, therefore I like to work to one significant figure, so I'm going to call that 2 parts per million methane and 400 parts per million carbon dioxide, and that's where I get my 200 times more dilute. But on short time scales, as a greenhouse gas, methane is 100 times more potent. So that gets you a ratio of 100 to 200, that's 1 to 2, and therefore you get something like methane being a third of the effect of the insulating effect today. And this graph here is straight out of the IPCC AR6, which shows that methane is indeed responsible for a third of our warming today. So if we can tackle methane gases in the atmosphere in a practical way, that actually is a massive opportunity. So one of the things that we've been looking at is the potential role of catalysts, photocatalysts. And the game of foot is this. The game of foot is literally to try and convert the methane in the atmosphere to carbon dioxide. If I could trap that carbon dioxide and store it as well, I would be a very, very happy lad. But I'm still going to be a happy lad if I can just convert the methane to carbon dioxide. And just think about this as a thought experiment. If we converted all of the methane in the atmosphere today at 2 parts per million to carbon dioxide, we would broadly see an accumulation of carbon dioxide levels equivalent to about 1 year of what we see in the atmosphere. But we would be taking a third of the insulation blanket away. So that's why the really big prize is just converting this stuff rather than necessarily trying to then deal with it in terms of storing it. So we're looking at different catalysts that have been researched around the world, and these are catalysts that, in the presence of things like UV light or with electrical charge, when the methane gas comes into contact with these catalysts, they're helped over the energy hump to convert to carbon dioxide. We know methane wants to go to carbon dioxide, otherwise we wouldn't burn the stuff to go and create electricity. But the problem is it's quite a stable molecule, and if it's in a really dilute, diffuse system, then if it does convert, the heat that's manifest as a result of that conversion is not sufficient to heat up the next molecule of methane because it's too far away and the heat gets diffused. So it only works for concentrated forms. But in the presence of a catalyst, the catalyst just helps the methane molecule get over the energy hump, the energy barrier, and then help it on its way to convert to carbon dioxide. So what we found is that there are a number of potential catalysts, photocatalysts, things like titanium dioxide. Titanium dioxide is staring you in the face right now. Titanium dioxide is why this wall here is as white as it is. These are really tiny particles that are used ubiquitously in industry today. So they're used in paint, they're used in sunscreen, they're used in toothpaste. So the last time I looked, that toothpaste is deemed to be safe for human consumption, safe for human. So we're not looking at materials that are necessarily going to be dangerous to humans. And that's really important in terms of just thinking about developing new materials and technologies for the built environment. So there have been different catalysts that have been looked at, but at the moment it looks like they're not really able to sort of be deployed in a way that is going to help us get to solutions for tackling methane in the built environment or other applications. So what we're doing is we're looking at what we might be able to do to enhance some of these catalysts. So instead of just looking at titanium dioxide, what are the benefits about decorating it with some metal nanoparticles to help them be even more effective at the conversion of methane to carbon dioxide. So where is this really going? It's going here. If you can develop a material that is good at converting methane, but that people want for another reason, we then have an opportunity to enhance the well-being of people and reduce, for example, maintenance bills that people will pay for today, even in the absence of certainly a methane price, but in the absence of let's say, a regulated carbon price. So I ran my own company for 12 years, and although I was trying to sell systems that reduce the energy consumption of buildings, so low energy ventilation systems, I quickly learned from colleagues such as the Foster Partners, that just selling a more expensive product to go and reduce somebody's energy bills is a hard sell. However, if you can sell a product that, for example, enhances the well-being, the air quality and the productivity of people, and by the way, Shaun, as a co-benefit, it happens to be low energy, you're on a much better footing to go and be commercially viable. And what we're looking at here on the left, on this diagram here, are some examples where certainly the building on the very far left is the Shard. Imagine being a window cleaner on that building. It's pretty horrible, and the bills are going to be fairly challenging. So yes, they've got window cleaning facilities there, but Pilkington, actually Pilkington, they already provide materials that are self-cleaning glass. So the idea being that when the rain hits that glass, it runs off really quickly and therefore doesn't build up. What are the coatings that they actually provide on self-cleaning glass? Those coatings are none other than titanium dioxide. So they already have a manufacturing facility and a process whereby they coat this glass, and all we're looking at is, can we enhance the material which they already have in their system to not only do self-cleaning glass, but be more effective at converting methane to carbon dioxide. So that's one of the areas that we're really looking at. And another area, which is, I think, arguably even more exciting, is back to my old business, which was looking at ventilation in buildings. And I got into this area thinking about energy reduction, but ventilation in buildings came to the fore in terms of it being really important, and the opportunities and challenges during COVID. So you may remember that during COVID, people were very exercised about the air quality in buildings, and how did you remove viruses in buildings? And there were two main areas. One was using very tight filters, HEPA filters, to try and remove any viruses that were introduced into the environment, and then before that air was then recirculated, using those filters to go and remove the viruses. And the other one was looking at UV lamps in ventilation systems to knock out viruses. So I then first of all got excited about the idea of a UV lamp in a ventilation duct, and then having that duct lined with something like titanium dioxide to then go and say, look, this is a great way of not only knocking out viruses, they've already paid for the infrastructure, but I also take out methane. Well, I ran the numbers, and then I was really excited about the idea, and then I realised it was a stupid idea. And the reason is that in order for the catalyst to have an effect on the air in terms of getting the methane to come out, the air's got to come into contact with that surface. And if you're even a half-decent ventilation engineer, you're going to use ducts that are reasonably large so that the air is not coming into contact with the surface of the duct, because that provides resistance and increases the fan energy. So that was, we realised was not the way forward. But another way is actually looking at back to the filters idea. If that filter can be impregnated with a photocatalyst, and you then put not only just a UV lamp but a filter in place as well, which doesn't have to be a HEPA filter if the UV lamp's doing the virus control, and combining the two, that gets really exciting. And then the last thing is that, well, why would somebody pay you an extra bit to go and convert methane to carbon dioxide? And answer first is I don't think they will. But that material doesn't just knock out methane. It looks at other carbon molecules in the air, and these are nasties called volatile organic compounds. So if you can actually devise a system which improves the health today, and people will then pay for that, and the methane conversion is just riding on the coattails of another system, I think we've then got real opportunities. So we're now looking at actually setting up a company and spinning this out as a result of some of the innovations on filter arrangements, the UV lamps, and the actual type of UV lamps. So we might go as far as to say we're going to use a UV lamp that might generate ozone, all right, which sounds horrible. In the UK it's allowed as long as you then have a very, very tight system to basically knock out the ozone before it gets into the space. And they're called charcoal filters. They're used to a plenty, they're really, really standard. So there are some really exciting ideas about the way that we might use buildings. And the last thing is, if you look at the amount of air being moved in the built environment, you find out that the amount of, you're not having to use fans like you do with direct air capture. Somebody's already paying the air to move through the buildings. So again, the amount of the volume flux of air that you see in the built environment is just absolutely enormous. So we're looking forward to then seeing whether we can actually use these ideas to have buildings not just reducing the emissions of the buildings, but having the buildings being part of the solution for actually removing greenhouse gases from the atmosphere.
That's very exciting. I didn't know any of that in terms of what that was possible, and for how I follow it necessarily. My name's Eliot. I am from the Cambridge Institute for Sustainability Leadership, so a Cambridge, travel halfway around the world to sit next to each other. CISL, we are part of the university, but we are a bit different. So we have less academic research and much more work with actors in the economy, so business, finance and government. And we exist to try and support different actors to be able to accelerate the transition. And what that means is thinking about the broad case for change, but also zooming into particular sectors and areas, of which the built environment is one that we're very keen on. We do a lot in the built environment, so notably we've been running a master's course in sustainability leadership in the built environment that's been going for over a decade, and is one of the kind of key qualifications that you can get for people who want to think about the built environment differently. We also, we work with startups and entrepreneurs. We know a number of innovators who are contributing to providing new solutions, maybe not quite as dramatic as that, but I think there are some really interesting ones coming through in that sense. And then we engage in some of the broader conversations, like thinking about the policy landscape and how business can help contribute to solutions at that level, developing the thought leadership that can really frame the question and help people to kind of unlock action. I guess the last thing that I'll say about what we do in the built environment is that we are an occupier of a building, and that's a key part of it because we renovate, we occupy a building in the heart of Cambridge. It's a 100-year-old building that when we took over, we renovated and retrofitted to bring it up to as many sustainability related, as many well-being related standards as we possibly could. And that's kind of key part of what this building is. The former telephone exchange, so it's the kind of building that like one of them exists in pretty much every British city. It's a very widespread building, and we wanted to show what was possible by delivering a renovation that was not excessively expensive but demonstrated results. We have a building that uses sort of 80 to 90% of its energy bills have been reduced by 80 to 90%. It uses less than 15% of its former energy use. The air quality is improved. It's kind of meets various standards in terms of well-being. The government is introducing a net zero 2050 standard. We're already compliant in that, and none of this costs more than the per square foot renovation cost was nothing unusual. It's maybe more towards the middle to upper end of that cost. So we have experience in terms of doing this. I personally, I think I've worked on sustainability and climate change for several decades, and I'm particularly glad we're talking about built environment because in some senses it's one of the sectors where I feel like it's frustrating that we are not further forward on this conversation. That it's a sector where 38% it's identified in that problem phrase as a significant part of the problem, and it's a sector where there are many solutions, as Matt said. And many of those solutions looked at in the context of the economy, or looked at in the context of return on investment over sort of like a number of years. They're close, they're affordable, they make a return, and yet we're not seeing that. We haven't made the kind of momentum. If you compare that to say the power sector, where you're seeing huge changes and accelerated progress of change. And so it's interesting to think about why. It's interesting to think about what some of the blockers of change are, even though that there is a lot of progress, but it's not sufficient. And we've been looking at this. I mean, whether it's some of the issues in terms of sourcing the right materials, or whether it's issues like the business case for renovation. And I think the common factor often comes down to a number of things. So one is a risk appetite in the industry. So there are obviously exceptions, but generally speaking, the risk appetite is in many cases quite low in terms of the broad range of it. So we're not seeing that kind of level of transformation and scaling. But maybe more critical than that is the question mark about where the agency for action sits and where the desire for change sits. So the decision making across the built environment value chain is often separated out. So you end up with different actors in the value chain looking at each other and saying, well, I would like this to be better, but I don't really have control. I could do this, but it's not in my interest. So the incentives and the decision making are not well aligned to achieve change. And this is one of the kind of areas that we are looking at and have been trying to work on. So I think as we think more about the solutions, it's interesting to see that there is the space for dialogue and there is space for dialogue. It's certainly been our experience with our building. So we had to kind of shake things up and work differently in terms of the process of the building. We had to get much more engaged in how we procured things, how we designed things, and so it's a much more hands-on process than was useful. For example, in the fit-out, we used quite a lot of circular products, so procured from Second Life, from things that had been often not actually used, but we had to. The challenge there was that the companies that usually make their margin from purchasing things from kind of agreed suppliers, and we were asking them to kind of completely break that down and have to work for a very different business model. If we zoom out, we kind of see this kind of in other areas where, for example, the widespread domestic house renovation is that often it's a thing that people would benefit from, but it never kind of quite cuts through in terms of the capital cost and their desire to kind of it's never a significant salient enough concern that it's the thing that people want to spend their limited pool of cash on. But many of the bodies working with those people actually have an incentive in encouraging better energy efficiency of homes, better energy use of homes. So, if you're a bank and you can see that you can reduce people's energy bills, then you are reducing the level of financial distress and you're improving repayment rates for the mortgages. So you're getting a better customer base out of it. If you're an insurer and you're making homes more resilient to the fluctuations in the climate, the impact of various things, then you're getting a more stable, more easy to manage, bigger market to address. If you're a government and you're reducing people's health concerns, you are actually reducing the amount of money that you need to put into alleviating those health concerns. So I think other people have talked about this, but what we see in the built environment is that there are these collection of benefits, but they sit with different people, and what we need to do is find ways to bring those people together and unlock that kind of benefit for everybody. So that's one of the things that we try and do. So we've been trying to kind of, for example, through our banking, we work with banks, we work with insurers, trying to get them to sit down with policymakers and make that case for that broader benefit and say that they are willing to support that, but they need government to kind of set that kind of policy case for action. I think that story also applies to the materials part of it and the value chain. We've been working a lot on the kind of industrial materials side, and when people think about, yes, steel and cement are absolutely going to be needed in the built environment. There are technical solutions to produce low carbon steel and low carbon cement. They're expensive, at least most of the ones that are currently usable and scalable. Often, the estimate is that the green premium, the additional cost of producing something that might be zero carbon, can be like 100%, it can be 150%, it can be more at the unit cost of production. But the thing is, at the level of the end use, the level of the cost of a building, the level of the cost of a car, the level of the cost of the final product, it's often more like 2% than 5%. So actually, if we, so again, we need to find ways to find those who've got the capability, the agency to make different changes, to be able to transmit that down the value chain. So for us, a lot of this is about, being able to connect that value chain, to be able to connect up different actors into the conversation, bring them together, and think about what the kind of the co-benefits are and how the system as a whole starts to address them.
All right, good stuff. Thanks, Eliot. Shaun, if I could just ask you to shuffle your foot slightly. Wonderful. Okay, excellent. So we've heard from the three of you there. Extremely insightful in lots of different ways, and I think we've covered a very broad spectrum here in terms of the opportunity across the built environment. I think one of the things that we always talk about, a lot of World GBC, so again, we're an industry organisation. Our members are national green building councils, but ultimately their members are the businesses involved in the built environment.